To Schrodinger's cat-in-a-box theory, where we will be testing in a hypothetical experiment Heisenberg's uncertainty principle. Now, here's how this is gonna work. We have here a cat in a box, a theoretical box. Now, the point of this is testing the uncertainty principle of electrons, naturally, as this is quantum mechanics. Now, according to the just kidding. We have here a Geiger counter, and we have here a tiny bit of radioactive substance, and we have here a diabolical device, as said by Schrodinger. Now, in 1 hour, there's a 50% chance that one of these atoms in the tiny bit of radioactive substance will decay. And if that happens, it will release electrons, which will be picked up by the Geiger counter, which will cause the diabolical device to set off and kill the poor kitty, which is obviously not desirable. So, let's see what happens. Oh, by the way, you can't see this. It has to be taken in. You cannot observe what happens. All of the sign. All of the sign. Get the sign. Get the sign. Hurry. 1 hour later. Well, the kitty has died because the diabolical device was set off, which is unfortunate. But now here's the tricky part. According to the quantum theory, while this was occurring, the cat was both dead and alive. Da, da, da. Cut. Today, we are looking at some of the people throughout history who have most greatly influenced our modern day atomic structure, or at least how we know it to be. The first guy is an ancient Greek philosopher named Democritus. He said that matter is divisible only to a finite point, and that there exists a smallest piece of matter.
Hi, I'm here to tell you about John Dalton. John Dalton created the law of multiple proportions in 1803. He also created Dalton's atomic theory, which is that matter is made up of atoms, and the atoms are indivisible and indestructible, which means you cannot destruct them. And also, he said that atoms of the same element are identical, but atoms of different elements are also somehow unique. And then lastly, atoms combine in a simple whole number ratio. Using this information, he created the very first atomic model. His atomic model is just a plain little circle or a marble. in which we have no idea what is inside, until this next person gave us a little hint of what's inside an atom. Please welcome Katie for our next speaker.
This guy's name is J.J. Thomson. He discovered the electron. He also discovered, using a cathode ray tube, super cool, that they are negatively charged. He also had an atomic model, the plum pudding model, which shows that inside, once thought to be a round sphere such as this, was little raisins of electrons which are negatively charged.
Okay. The next person now is Robert Millikan. Thank you, Katie, for doing that unneeded introduction. That was my introduction. Okay. Robert Millikan used the oil drop experiment to determine the charge of a single electron, which was -6 times 10 to the -19 coulombs. Yes, never heard that before, have you? Neither have I. And now, the mass of an electron. 9.1 times 10 to the -51 kilograms. That sounds much better. Yes, it does. And he didn't have an atomic model. So we cannot change our model, and we are still at the plum pudding model, which is the atom, and there's a bunch of plum pudding inside. I can hear it swishing around. I can hear a yummy little electron raisin screaming for help. Now I'm bringing back Katie. Welcome back, Katie. Here's your model.
In 1909, Ernest Rutherford did the golden foil experiment, in which he discovered the nucleus. Wow, super cool. This is his new atomic model, including said nucleus.
Our next person is Niels Bohr. Niels Bohr discovered energy levels. I know, they are so interesting. But this also caused him to create a new atomic model, which is the Niels Bohr model, which is the one that we mostly work off of today, it's just a model. It's a very nice model, but we don't go off it today.
Our last and final person is Mr. James Chadwick. He discovered the neutron, and in doing so, created the actual last one that we look upon today. Oh, so beautiful. There you have it. He had another atomic model that looks something like this.
Pretty sure it's the plum pudding model.
It is the plum pudding model. Look at those little raisins of electrons thrown in there into positive goo, like gumbo on a sunny day.
What are you doing?